Okay, so this next section is about the ideal gas law. I want to talk about here the standard temperature and pressure. It's reference conditions, which means that it's just so that it's universal across the world. That 0 degrees Celsius will be the temperature, so this stands for temperature and pressure, standard temperature, pressure. And the pressure is 1 atmosphere. Okay, so I expect you to know that if it says that something is at STP, that means it's 0 degrees Celsius and 1 atmosphere. And the volume of 1 mole of gas at STP is always 22.4. So the volume of 1 mole at STP is equal to 22.4 liters. And that's universal. It doesn't matter what the density of the gas is, that if I have 1 mole of it and it's at STP, it's 22.4 liters. Okay? All right, so I have pressure, volume as moles RT. Okay? So pressure, P, has to be in atmospheres. Okay? Volume in liters. N is the number of moles. R is a constant. What does that mean? Okay? This constant here. It means that for every one of these type problems, that the value is going to always be 0.0808258. I typically shorten that to 0.0821. It's given to you on the periodic table, but you need to know that. And so the molar gas volume constant R is the proportionality constant between the molar volume to temperature and pressure. Okay? Now, like I said, it's given to you on the periodic table. There are a couple of different values depending on what units you use. We're going to be using 2 of them this semester and next semester. Okay, here's the one we use when we're dealing with pressure, and I know that because the units are in atmospheres. And this is the one we use when we're dealing with energy or with speed. You'll notice that these are all the same value here. So the meters per second also. So we're going to be using, I'm just going to say these 2 because the value is the same whether it be in joules or kilograms meter squared per second squared. We're going to be using both of these values. Both are given to you on the periodic table, but you're going to need to know which one to use when. Okay? So let's do a problem. Okay? Number 60 in the book says, according to your calculations, a reaction should yield 6.6 grams of oxygen. What do you expect the volume to be at 23 degrees Celsius and 0.985 atmospheres? So I'm going to start this the same way. I have 6.67 grams of O2, and that is a mass. It says, what do I expect the volume to be? So the volume is what I want to look for. I have 23 degrees C, and that's temperature. And I have 0.985 atmospheres, and that is pressure. Okay? So you'll notice that this problem is different than anything else we've done so far in this chapter because I only have 1 volume, 1 temperature, and 1 pressure. Okay, so when we did Boyle's law, we had 2 pressures and 2 volumes. One of them was unknown. When we did Charles's law, I had 2 volumes and 2 temperatures, and one of them was unknown. And then in the confined gas law, I have 2 volumes, 2 temperatures, and 2 pressures. So I had 2, 2, and 2. All right. So this is the ideal gas law. PV is equal to nRT. Okay. This has to be in atmospheres, which it is. This has to be in liters, which means my answer is going to be in liters. This is the moles. This is that. R, like I said, is a constant, so it's going to be 0.0821. And temperature has to be in Kelvin. So I need to add the 273 here to give me 296. Before I solve, I need to find N. Okay, N is the number of moles. So N is mass divided by molar mass. The molar mass of oxygen is 32.000 grams per mole. So N is my 6.67 divided by 32.00, and that gives me 0.208 moles. Okay, so now I'm ready to start substituting in. I'll go over here. So my pressure is 0.985. V is my unknown. 0.208. 0.0821, and 296. So this stays 0.985. When I multiply these three things together, I get 5.055. So my V, dropped V. V is 5.055 divided by 0.985. So my volume is 5.13, and the units are liters. Okay. All right. Next one. I would suggest stopping this video, trying to do this one on your own before I would do it, and see if you get the right answer. Okay. Same process. I have what's given. I have 2.50 liters. Liters is a unit of volume. I have 5.65 grams of C3H8, and that's a mass. It tells me that the pressure was 741 millimeters of mercury, and it wants to know this time what is the temperature. So my temperature is my unknown. Okay, again, I have one volume, one pressure, one temperature. Okay, so I'm going to use the ideal gas law of PV is equal to nRT. Okay, pressure has to be in atmospheres though. So on slide 1, we said that 1 atmosphere was equal to 760 millimeters of mercury. So I'm going to take the 741 divided by 760, and I get 0.975 atmospheres. Okay. Volume is already in liters, so I don't have to touch that. Moles, N, is the mass divided by the molar mass. The molar mass is 3 times the 12.01 plus 8 times 1.01. I started to do that in my head. Gives me 44.11. So N, over here, N is 5.65 divided by 44.11 to give me 0.1281 moles. Okay. R is the constant, so I'll write that here. R is 0.0821, and temperature has to be in Kelvin, but I'm solving for temperature, so that's all I have to do. So now I'm going to start substituting my numbers in. Okay, my pressure was 0.975. My volume is 2.5. My N is 0.1281. My R is 0.0821. And my temperature is what I don't know. So I'm going to multiply these two numbers together, and I get 2.438. I multiply these two numbers together, and I get 0.01052T. I don't believe that one. Let me double check that one. 0.1281 times 0.0821. Make sure I entered it right. Yeah, I did. Okay. I finally got smart and did the math ahead of time, but I just didn't believe that number. So I'm going to divide both sides by 0.01052. So T is 2.438 divided by 0.01052, and that gives me 232 K. Okay, it doesn't specify, so you can leave it in Kelvin. If it asks for the temperature in Celsius, which your worksheet does, then I would need to minus 273. And I didn't do that one ahead of time. 232 minus 273 gives me a negative 41 degrees C. You can stop here for this problem because it doesn't specify. If it does specify, then you would need to go on to here. Okay. All right, so this is going to be the end of this part 1, and there'll be a part 2 on this video also.